In this section, we're going to look at amines as nucleophiles. So amines are R bond N, bond H, bond H, okay? And it has a lone pair on this nitrogen, which can act as a nucleophile. This is an example of a primary amine. Why is it primary? Because the nitrogen is attached to one carbon. The other kind we're going to look at are these types of amines, which are secondary amines as nucleophiles. And what you're going to find is the reactions with primary amines and secondary amines with carbonyl containing compounds are quite different. Because these molecules are a little bit more complex, I'm going to leave off the R nomenclature on some of our aldehydes and ketones and just use lines instead. So let's take an example here of adding a primary amine and adding a secondary amine as the nucleophile. So here we have C bond H bonded to C, double bonded to O, and bonded to something else. So this could be an aldehyde or a ketone, and I'm just leaving these as lines instead of having R and R prime and R prime prime and all this kind of stuff. And I'll leave the R's for our amines. In this case, a primary amine. When we add a primary amine to an aldehyde or a ketone, okay, what we end up with is this C, H, and all this goes along for the ride. The C double bond O is now C double bond N bond R. And then this is attached to something else. So what have we done here? Well, we've lost H, and we lost O, and we've lost two H's. So essentially, we've lost water. This double bonded N, R thing, is called an imine with an I. Okay, instead of an amine with an A. So this is called an imine that can form with a primary amine. Now, what happens if we use a secondary amine? So we need this again. And you'll see why this is now being written out when you see this one. Here we have R2 and H. Now, it doesn't necessarily have to be that these two R's are the same, but for simplicity, they will be. And again, we have this lone pair, and again, this lone pair can attack and kick this up here. But in this case, we actually end up with a double bond here. And we get C bonded to two things, double bonded to C. This is this C. This is this C. This is bonded to one thing, and the other thing that it's bonded to is N R2, like that. So essentially, we have added the amine, but we've also created the double bond. This is called an N-amine. N for alkene, amine for amine. So this is an N-amine. Take-home message. When we add primary amines, we make imines. When we add secondary amines, we make enamines. Now what I'd like to do next is look at the two different mechanisms for this reaction, and then we'll do a couple of examples where we decide whether we're going to make an imine or an enamine. So let's look at the imine mechanism first. So here, we're going to have a primary amine, and I'm going to use this as my aldehyde or ketone. All right, again, to avoid all the R's, I'm going to just leave those as blank bonds. So we have N bond H2R, which again is a primary amine. It's still going to undergo this nucleophilic addition. Well, here, our nucleophile is this nitrogen lone pair, and this is going to kick up there. So no difference between what we've seen up until now and this one. And we get N bond H bond R with a plus charge. Okay. We get this still bonded to two other things, and we get an O minus. Now we need to deprotonate this and protonate this, and the order is not super important. So I'm going to use water as my protonator and deprotonator, but of course it would depend on the exact case. So here we have this coming in here and kicking in there, and what we end up with is C bond N bond R bond H, still bonded to two things, bond O minus, and now either water or H3O plus. All right, if we get the proton from here, we could call it H3O plus, comes in, and basically we get C bond N bond R bond H bond OH. Now, this is not where the reaction stops, because if we lose this water, we make a more stable molecule. So if we lose this OH and this H, we make a more stable molecule. Well, in order to lose this H, we need to protonate this H. All right, this O, because this OH is going to not be a good leaving group. It's a pretty strong base. But if it's water, if it's protonated OH or water, then it is a good leaving group. So the first thing we do is protonate it, and we get OH2 with a plus charge here, bonded to our carbon, which is bonded to two other things, which is bonded to an R bond N bond H. Remember that this nitrogen has a lone pair. We lost the H here, and that came on as a lone pair. I haven't been showing it every time because we haven't needed it, but now we need it. Now what happens? We get this to come in, this gets kicked out, and we get a C bonded to two things, double bonded to an N, okay, which is bonded to an R, an H, and there's nothing up here. But now we have 4 bonded nitrogen, so this is plus. What do we need to have happen? Well, what we need to have happen is something to take this away. So I'm going to use water, grabs this resumes the lone pair, and what we end up with is a C bonded to two things, double bonded to an N, bonded to an R, like so. This, okay, is your imine. So this is the mechanism. It's quite a long mechanism, but we're able to lose the HOH. So basically, once we get to here, this is exactly what we've seen several times before. But here we can have this dehydration and lose this water molecule to form this imine. Let's look at the enamine mechanism. So in this case, we have the N-amine being formed. Remember that means we need to use a secondary amine, a secondary amine. All right, so here we have CH bonded to two things, bonded to C, double bond O, bonded to something else. We have NHR2, a secondary amine. So in the previous example, we had a primary amine. This, again, has a lone pair on it. This X is the nucleophile. This gets kicked up. Same as before. All right, so what we end up with is C bond H, bonded to two other things, bonded to C, bonded to now O minus, bonded to one other thing, bonded to N, H, R, R, and this has a plus charge. Here, we're going to get a similar thing happening that happened before. When we look at this molecule, we need to lose this proton. So essentially what happens is we have something like water come in, grab this proton, and that kicks there. And what we end up with is a C bond H bonded to two things. Okay, this isn't actually bonded to the R, it was just written underneath it. Bonded to a C, bonded to an O minus, bonded to an N, bonded to an R, bonded to an R. This is now neutral. This minus charge, so we have some H3O plus or something, can grab this proton. And just like before, we have C bonded to an H, bonded to two other things, bonded to C, bonded to an OH, bonded to an N, bonded to an R, bonded to an R. Now, if you remember last time, we talked about how the reaction didn't stop here. And we lost an H from the N and the OH in order to form water. But if you notice here, there is no H on the end. That's what makes the secondary amine different. But we have this H. So what's going to happen here? Well, we need to make this a good leaving group. In order to do that, okay, we would have something. Give it a proton. All right. And we end up with C bond H, bonded to two things. Bonded to, that should be a C. Bonded to C, bonded to OH2 with a plus charge. Bonded to N, bonded to two R's, which I haven't needed it, so I haven't been drawing it, but the lone pair on the nitrogen. This drops in, that gets kicked out. And what we end up with is a C bonded to an H, bonded to two things. Bonded to a C, double bonded to an N bond R with a positive charge. The difference is there's no H to lose here, but because we have this structure, this proton actually becomes acidic. Because if it loses this, then this can regain a neutral charge over here. So in this case, we have something, grab this, I'll use water, grabs this proton, okay, like so. This shifts into a double bond, and that lone pair shifts back onto nitrogen. And what we end up with is C bonded to two things, double bonded to C, bonded to, I'll draw it down here so you can see it, bonded to N, bonded to R, bonded to R. All right, this is called an enamine. N for alkene, amine for amine. So the difference between a primary and secondary amine is quite different, and it all rests on not having that H to lose here. Since you don't have that H to lose here, you lose this H instead, and when you lose this H, you form the alkene. Let's look at two examples of this molecule. So in this case, we are going to turn this molecule, CH3, C double bond O bond CH3, acetone, and we want to make two different things. We want to make CH3, C double bond N, CH3, CH3, okay. This one is the imine, and then in the other case, we want to make CH2 double bond C bond N, CH3 2 bond CH3, the enamine. Well, what is the difference between these two things? The difference between these two things is whether we add the primary or the secondary amine. In this case, to make the imine, we need to add the primary amine, which is CH3 NH2. And to make the enamine, we need to add the secondary amine, which is NHCH3 2. All right. In this case, I needed a CH3 because it has a CH3. In this case, I needed to add two CH3s because it has two CH3s. So similar mechanisms, but slightly, I don't even know about slightly, different products based on the deprotonation of the amine or the deprotonation of the carbon-containing group. In the next two sets of reactions, we're going to look at two named reactions. I'm not going to talk about the mechanisms, but they are useful reactions for doing specific things to aldehydes and ketones. So we'll look at the types of reactions and what is formed from those two types of reactions.